This is 8.4 in your textbook, surface area of right pyramids and cones. First of all, to define a right pyramid, it's a pyramid whose base is a regular polygon. So when we talk about a regular polygon, who knows what that means? Matthew.
Polygon
Yeah, another, not so much its angles, but
Sideline?
yeah, its side lengths are the same. So it's a regular polygon, so it could be 4-sided, 5-sided, but those side lengths are the same, and whose top vertex is directly above the center of the base. So it's a pyramid, a polygon that's going up to the center. So here's a square pyramid, square base pyramid. It says calculate the surface of a square base pyramid. So basically in all these questions, you're going to have a three-dimensional shape, and you want to make it two-dimensional so you can calculate the surface area. Remember, we're not doing the volume, we're not doing the interior volume, we're just doing what's on the outside. So if we can take this 3D shape and convert it to a 2D shape, and then calculate the surface area of each 2D shape and add them up, that'll give us our answer we're looking for. So in this particular case, if you can imagine, there's 4 sides to this pyramid. We've just peeled them open. Okay, so we just peeled them back, and then what we expose is a square base with 4 kind of flaps that come off and meet up. Okay, so you're going to use the dimensions from the question and then try to label your 2D shape. All right, so it tells us that the base is 10, so I've labeled them 10 by 10. It's asking us for the surface area. We don't know the height of this triangle, or the slant height. So this height here is this height here. Okay, so we need to figure that out. So first and foremost, we can calculate the area of the base, which is just 10 times 10, which is 100. So the area of that triangle now, to figure out what that slant height there is this. So this triangle is actually this triangle here, where h is going to be this value here. So it's the slant height. So we have the height, which is 12, so that's given from the problem. And then we have the distance from the center, which is obviously half of 10, so we know that's 5. So given those 2 pieces of information, we can calculate the hypotenuse. Okay, so we use our formula. The hypotenuse squared is equal to side 1 squared plus side 2 squared. And we solve for the hypotenuse, which is just 13. So now we have this value here is equal to 13. Okay, so we have 1, 2, 3, 4 of them. We need to find the area of each one of these triangles. So it's 1/2 base times height. 1/2 times 10, which is the base, times the height, which we know is 13 now. So we get 65. So the total surface area of this pyramid then is the area of the base, which is only one of them, plus 4 times the area of each one of these triangles. Okay, so we sum that up to 360. Any questions there? All right, example number 2. So quite a little bit more complicated shape. Again, it's a pyramid, but it has kind of like a box as a base. Okay, so I drew it the best that I can. You can look in the textbook for a better drawing. But it's a 1, 2, 3, 4, 5, 6. It's a hexagon here. So a 6-sided base. So coming up from each one of those sides of the base is kind of a box shape. So you can see that here. All I've done again is I've peeled it back. So if you can imagine like peeling a banana from the center, you're peeling back each side. Again, it's important to recognize that these are regular polygons, so all of these sides are the same. And all of these sides are the same, etc. Okay, so that helps us when we do our calculations. So the first thing we wanted to find out is the area of the trapezoid. Again, we've asked to find the total surface area of this particular shape. So you peel it back from a 3D to a 2D shape. The area of a trapezoid we know by this formula, base 1 plus base 2 divided by 2 times height. So here's our trapezoid that we're looking at, right in here, this shaded area. So one of our bases is 16, the other one is 8. So we have our 8 plus 16 divided by 2 times our height, which we know is 6.9, which is given here. It's kind of awkward to see, but this is cutting through the hexagon, right through the base in the center. So we know that the height of that particular trapezoid is 6.9, which again is drawn out here. Okay, once we get the area of our trapezoid, we know our hexagon is 2 of those trapezoid. It's mirrored. So we times it by 2. So that 82.8 times 2. Finally, we're going to find out our area of our triangle, which is this piece here. It's just 1/2 base times height. We know the base is 8, and we know the height is 10. So that's easy enough. We get 40 for the triangles. The rectangles, we know that the length is 8 and the height is 3, also given. So we have our rectangles. The only trick when finding the total surface area is you need to multiply those triangles by 6, because there's 6 of them, as well as for the rectangles. Multiply by 6 because there's 6 of them. And then add them all up. Okay? Moving on, example number 3 again, a pyramid. Again, we're peeling them back. This time it has 1, 2, 3, 4, 5 sides. We're looking for the surface area, so we're going to find out for the triangles and then as well as for the base. Okay, so the process is the same. You're taking a 3D shape, peeling it back. Lastly, I want to just show you example 4, surface area of a cone. You're going to take the area of the base, which is the area of a circle, so it's pi r squared, and you're going to add that to the area of the curved surface. And here's the formula for the curved surface. Okay, it's pi r times L, where L is your slant height and r is your radius. Okay, Matthew? For which one? You probably have to calculate it using the radius and the height. Yeah, see that would make a triangle like this? Okay? Alright, that's it.
Are you going to post on YouTube?